Welcome to our deep dive, and today we're going to be looking into the snake of the Chinese Zodiac.
Cool.
As you may or may not know, the Chinese Zodiac is a 12-year cycle, each year represented by a different animal.
Right.
And each of those animals is believed to imbue those born under its sign with certain characteristics and destinies. We're going to be using the Wikipedia article on the snake zodiac as our main source for this deep dive.
Sounds good.
So I guess to start off, I'm kind of curious how the snake even made it into the zodiac.
Oh, yeah.
What's the story there?
Well, legend has it that there was this big race
Okay.
to determine the order of the zodiac animals, and the snake, not exactly known for its swimming skills,
Right.
devised a clever plan.
Okay.
It hitched a ride on the horse's hoof, staying hidden until the very end.
Oh, sneaky.
And just as the horse was about to cross the finish line, the snake sprang out, startling the horse,
Oh, wow.
and securing sixth place for itself.
That's pretty impressive.
Yeah,
It speaks to the snake's cunning and intelligence for sure.
yeah, it does.
And speaking of cleverness,
Yeah.
did you know that each zodiac animal governs a specific 2-hour period? And the snake's hour is between 9 and 11 a.m.
Oh, wow.
The time when snakes typically emerge as the sun warms the earth.
Interesting.
It makes you wonder if people born in the hour of the snake
Yeah.
share some of those traits like adaptability and resourcefulness. Like
Yeah.
they emerge
Yeah.
when the conditions are just right.
That's a good point.
And it's also worth noting, I think that the characteristics of a snake ear are further nuanced by the 5 elements.
Right.
Metal, water, wood, fire, and earth.
Yeah, those elements play a big role.
Each element's associated with specific years, adding another layer to the personality of those born under the snake sign.
Definitely.
So someone born in, say, 1977 would be a fire snake, while someone born in 2013 would be a water snake.
Right.
What about 2025?
Oh, good question.
What kind of snake year is that going to be?
Well, 2025 is going to be the year of the wood snake.
Wood snake, okay.
And you can actually find your own snake year and element combination in the list provided in the Wikipedia article.
Yeah, be sure to check that out. It's amazing how these ancient systems weave together different elements to create such a complex tapestry of meanings.
It really is.
We've touched upon the snake's intelligence,
Yeah.
but the article also mentions this tendency to lack scruples.
Oh, right.
This makes me wonder, is there a potential shadow side to the snake's cleverness?
I see what you mean.
Is there something else there?
It's an interesting point.
Yeah.
Intelligence is definitely a defining characteristic of the snake. But this lack of scruples,
Yeah.
it suggests a strategic mindset
Okay.
that prioritizes maybe personal gain or ambition.
Okay.
It doesn't necessarily imply malicious intent,
Right.
but rather a willingness to kind of bend the rules or navigate situations in unconventional ways.
Oh, it's like a double-edged sword.
Yeah, you could say that.
The same intelligence that allows them to achieve their goals can also lead them down a path.
That others might consider less ethical.
Yeah, that's true.
So it definitely adds a layer of complexity to the snake personality.
It does. It does.
Speaking of uncovering,
Yes.
I'm kind of curious about some of the other astrological associations connected to the snake.
Sure.
What can you tell us about that?
Well, in Chinese astrology, the snake is believed to possess yin energy,
Okay.
which is associated with being receptive, introspective, and intuitive. It suggests a connection to inner wisdom
Okay.
and a preference for contemplation rather than like impulsive action.
So they think before they act.
Exactly.
It's almost like the snake observes and assesses the situation before making a move, carefully calculating its next step.
Right. Makes sense.
Now, if you're interested in lucky numbers,
Oh, yeah. Always.
the snake is associated with 2, 8, and 9.
Oh, good to know.
And for lucky colors, we have red light, yellow, and black.
Okay.
And it's interesting to note that both orchids and cacti are considered lucky flowers for the snake.
Wow. That's quite a contrast.
Yeah, isn't it?
It's like a delicate orchid blooming in the desert next to a prickly cactus.
Yeah, I like that.
Almost speaks to the duality of the snake's nature.
It does.
Yeah. So it sounds like there's a lot we can learn from the snake.
Definitely.
So much wisdom to unpack.
For sure.
And speaking of learning, what about compatibility?
Well, yeah.
Who meshes well with the snake and who might want to kind of tread carefully?
Well, according to Chinese Zodiac tradition, the snake finds harmony with the ox and the rooster.
Okay.
They complement each other's strengths and create a sense of balance.
Interesting.
Yeah.
What about those who might clash with the snake's energy?
Well, the snake and the pig are considered to be the most incompatible pairing.
Oh.
Their personalities and approaches to life tend to clash.
Really?
Yeah, which can lead to conflicts.
So if you're a snake and your best friend's a pig, you might want to approach things a little more carefully.
That might be a good idea.
With a bit more sensitivity and understanding. It's important to remember, though, that these compatibility assessments are based on traditional beliefs.
Yeah.
Ultimately, the dynamics of any relationship depend on individual personalities and the willingness to navigate those differences with respect and compassion.
I agree.
It's fascinating to explore these ancient systems.
Yeah.
But it's also important to remember that they're not like definitive guides.
Right.
Each individual is unique and relationships are complex. There's always more to the story than what meets the eye.
Absolutely.
The Chinese Zodiac provides a framework for understanding.
Yeah.
But it's up to each individual to interpret and apply its wisdom in a way that resonates with their own experiences.
I think that's a great point.
Wow, there's a lot to the snake zodiac.
Oh, yeah.
It makes you wonder if there's any other surprises waiting to be uncovered.
Well, there's always more to learn.
Okay.
One little detail I find pretty fascinating is that the snake year is sometimes referred to as a little dragon year.
A little dragon year.
Yeah.
Is that just to boost the ego of snake-born folks, or is there something more to it?
That's a common belief.
Okay.
But, you know, its origin is a bit of a mystery.
Oh, really?
It could be, because both the snake and the dragon are seen as powerful and wise, transformative figures in Chinese culture.
I mean, the dragon with its strength and majesty.
Yeah.
That's a pretty obvious symbol of power.
Right.
How does the snake fit into that, though?
Well, think about it.
Okay.
The snake's ability to shed its skin.
Okay.
It's a symbol of rebirth, renewal, and the constant cycle of transformation.
Okay.
And this really resonates with the dragon's association with growth and change.
I see it.
Even though they look different.
Yeah.
And have very different approaches.
So maybe the little dragon label is talking about the snake's hidden potential for growth and transformation.
Exactly.
Like a smaller, more subtle version of that dragon energy.
I think that's a good way to put it.
Okay, cool. Yeah. So we got cleverness, intelligence, a touch of mystery, and now this potential for profound transformation.
It's quite a combination.
Yeah, it is.
And don't forget about that lack of scruples we talked about earlier.
Oh, right.
Adds another layer to this snake personality.
Yeah.
Suggesting that their path to transformation might not always follow the rules.
So their transformation is more about changing how they think.
Yeah.
And embracing new perspectives.
Right.
Even if it ruffles some feathers.
Exactly. It's about embracing change.
Okay.
Adapting to new circumstances and constantly evolving. Just like the snake sheds its skin to reveal a new layer underneath.
Okay.
Those born in the year of the snake might go through periods of shedding old habits, beliefs, or even relationships.
Oh, wow.
To make way for personal growth.
So what does this all mean for our listener?
That's a good question.
Especially with the wood snake year coming up in 2025.
Well, whether or not you believe in the Chinese Zodiac, this deep dive gives us a chance to think about our own ability to transform.
Okay.
What parts of your life are ready to be shed?
Wow.
What new beginnings are you ready for?
That's a great point.
Yeah.
It's like the snake zodiac is telling us that change is going to happen, and we have the power to choose how we deal with it.
That's right.
It's like a call to step into our own potential for growth and renewal.
Like the snake.
Exactly. You know, it's really amazing how these ancient systems of knowledge, like the Chinese Zodiac, can be so relevant to us today.
Yeah, they really do offer some timeless wisdom.
Like the snake in particular reminds us that transformation doesn't have to be this big, dramatic thing.
Right.
It can be these subtle shifts in how we see things. Right. Letting go of old patterns and embracing the fact that we're always evolving.
Constantly changing.
It's kind of like that little dragon idea we were talking about.
Oh, yeah.
It's not about becoming a completely different person.
Right.
But more about tapping into our inner strength and potential.
To be our best selves.
Yeah, exactly.
It's about recognizing that we're all always becoming. And that embracing change is essential to grow and be fulfilled.
Well, I think we've given our listeners a lot to consider today.
I hope so.
Whether you're a snake in the Chinese Zodiac or just someone trying to navigate the year ahead.
Right.
There's definitely a lot we can learn from this deep dive.
The snake encourages us to be adaptable and resourceful.
Yeah.
Open to change. It reminds us that even when things are tough, we can let go of what's holding us back.
Right.
And come out stronger and wiser.
And maybe a little dragon, too. Maybe so.
Thanks for joining us on this deep dive into the world of the snake.
It was my pleasure.
Until next time, keep learning, keep exploring, and keep embracing your own personal transformations. Welcome to the deep dive. This time, we're getting seriously small, like unbelievably small. We're talking atoms, the building blocks of everything around us.
The very fabric of reality.
Exactly. And today we're diving deep into excerpts from the Wikipedia article on atoms. Believe me, it's a journey.
It really is.
We're going from ancient philosophy to quantum mechanics in just a few deep dives.
That's right. We're talking about the foundation of matter itself. It's pretty wild to think about.
It really is. And what's fascinating is how it all started. Long before microscopes, even before we could really test any of it, people were already pondering, like, what the universe was made of.
Yeah, the ancient Greeks, talk about thinkers ahead of their time. They came up with the word atomos, meaning uncuttable.
Uncuttable.
They imagined these tiny, indivisible particles as the fundamental building blocks of, well, everything. It's remarkable how those early minds worked, trying to understand the invisible.
It's like they intuitively knew there had to be some kind of fundamental limit, right? That you couldn't just keep dividing things forever.
Exactly. And that's a concept that's key to grasping the significance of what John Dalton did centuries later in the 19th century. He took this philosophical idea and turned it into a scientific theory.
So how did he bridge that gap from philosophy to actual science?
Yeah.
What was Dalton's big aha moment?
Well, he was studying the way elements combine to form different compounds. For example, he was looking at tin oxide. You know, that stuff you find in things like ceramics and solar panels.
Okay, so he's studying this tin oxide. What's so revolutionary about that?
He noticed that elements always combine in fixed ratios, like clockwork. Take tin oxide. You always have a specific ratio of tin to oxygen. This led him to realize there must be some fundamental unit, a smallest possible piece of each element that combines in whole numbers. He called it the atom.
It's like realizing you can only build with Legos in certain combinations, right? 2 red bricks for every blue one. You'd think, there must be a reason for this, a system.
Precisely. Dalton's genius was in recognizing that those fixed ratios pointed to something fundamental about the nature of matter itself. There had to be some basic building block. And that's where our understanding of the atom as a scientific concept really takes off.
Okay, so now we have these fundamental units, atoms, but we're still a long way from understanding what's inside them, right? It's like we've discovered the Lego brick, but now we need to figure out what it's made of.
Exactly. And this is where our atomic detective story gets even more exciting. Because along comes J.J. Thomson at the end of the 19th century, and he discovers a particle even smaller than the atom, the electron.
The electron. Okay, for those of us who need a refresher, what exactly is an electron?
Think of it as a tiny particle that carries a negative electric charge.
Okay.
It's what makes electricity flow. Now, what really shook things up was how incredibly light electrons were compared to anything else they'd found, like way lighter.
Whoa, hold on. So we've got these incredibly tiny, negatively charged particles. But if atoms are supposed to be the smallest unit of matter, where do these electrons fit in?
That's the question that puzzled scientists at the time. Thomson proposed a model, the plum pudding model, to try and explain it.
A plum pudding?
Yeah. Imagine a positively charged sphere, the pudding, with these negatively charged electrons, the plums, embedded throughout.
Okay.
It was a start, but it didn't quite capture the whole picture.
A positively charged pudding with negatively charged plums. That's an image that definitely sticks with you.
That's a good one.
But I'm guessing that model didn't last very long, right?
You're right. Things got really interesting with Ernest Rutherford's gold foil experiment.
Okay, the gold foil experiment. Now that rings a bell from high school, but to be honest, I can't remember exactly what went down.
Well, imagine this. Rutherford's team fired tiny atomic bullets, alpha particles to be precise, at a thin sheet of gold foil.
So they were basically shooting tiny particles at what amounts to like really, really thin gold foil.
Pretty much.
What were they expecting to see?
Well, if the plum pudding model was right, those alpha particles should have zipped right through the gold atoms with maybe a tiny deflection here and there, like shooting BB pellets through a cake.
Okay.
Messy, sure, but no major surprises.
Okay, that makes sense. So what happened? Did those tiny bullets go straight through like they expected?
Here's the mind-blowing part. Some of those alpha particles bounced straight back. Can you believe it? It was like those tiny bullets hit a wall.
Whoa, seriously. That's about as unexpected as it gets in physics, right? It's like throwing a pebble at a tissue and having it ricochet back at you. What was going on?
That's the million-dollar question. And it led to a huge breakthrough. Rutherford realized that in order for those alpha particles to be deflected like that, the atom couldn't be a homogeneous pudding. It had to have a tiny, dense, and most importantly, positively charged core, which he called the nucleus. Those ricocheting alpha particles, they were bouncing off that tiny, dense nucleus.
That's incredible. So no more evenly distributed positive charge like in the plum pudding. We've got a concentrated nucleus. That's a game changer for our understanding of the atom.
Completely revolutionized atomic theory. But you know what happens when you solve one mystery?
What's that?
A whole bunch more pop up.
Oh, I know that feeling all too well. What kind of questions did this discovery raise?
Well, think about it. If you have negatively charged electrons hanging around a positively charged nucleus, shouldn't they just crash into each other?
Yeah, that's what I'm thinking. It's like asking why the planets don't just spiral into the sun. If there's this force of attraction, shouldn't everything just collapse? It's like the universe's tiniest game of keep away, with these opposite charges constantly attracting each other. What's keeping those electrons from spiraling into the nucleus?
That's the million-dollar question that had physicists scratching their heads. And to tackle it, we need to bring in another brilliant mind, Niels Bohr.
Bohr. Okay.
In 1913, he proposed a model that tried to reconcile this very problem.
All right, Bohr to the rescue. Lay it on me. What was Bohr's solution?
Bohr's model introduced the idea of quantized orbits. Picture this. Electrons aren't free to zoom around the nucleus just anywhere. They're confined to specific energy levels. Think of them like lanes on a racetrack.
Okay, so instead of whizzing around willy-nilly, electrons have these designated lanes they have to stick to. I'm starting to see where this is going.
Exactly. Electrons can jump between these lanes or energy levels by absorbing or emitting energy, but they can't exist in between. It's like a video game character that can only move between specific platforms, not just float anywhere in midair.
So electrons have these assigned parking spots around the nucleus and need a jolt of energy to switch spots.
Yeah.
But hold on a second. We were just talking about how electrons are unbelievably tiny compared to even the tiniest nucleus, right?
You're picking up on a crucial detail. Even with these quantized orbits, there was still this nagging question of mass.
Ah, I see. It's like the universe was hiding a secret ingredient in the atomic recipe. What were they missing?
Remember, almost all of an atom's mass is concentrated in that tiny nucleus. And while protons were definitely part of the story, they couldn't account for all of it. It's like baking a cake and realizing it weighs twice as much as the ingredients you put in.
Wow.
Right.
There had to be something else lurking in there, adding to the mass of the nucleus. So what was the mystery ingredient?
Enter the neutron. This elusive particle was finally discovered by James Chadwick in 1932, and it was the missing piece of the puzzle.
The neutron.
Ah.
The stealthy resident of the atoms.
Yeah.
Tell me more about these neutrons. How do they fit into the picture?
Well, neutrons are electrically neutral, hence the name, but they have a mass very similar to a proton.
Okay.
And guess where they hang out? Right there in the nucleus with the protons. This explained the extra mass scientists had been puzzling over.
It all starts to make more sense now. We've got protons and neutrons huddled together in the nucleus, providing the atom's mass, and these tiny electrons zipping around in their designated energy levels.
That's a pretty good picture of the atom as we understood it at the time.
Uh-oh.
But there's always a twist, isn't there?
Oh, I have a feeling I know what's coming. There's always more to the story. What's the twist this time?
Chadwick's discovery of the neutron led to another fascinating realization. Atoms of the same element could have different numbers of neutrons. We call these variations isotopes.
Isotopes. Now, those I have heard of, like carbon-12 and carbon-14, right? Something about them being used to date really old stuff.
You got it. Same element, carbon, but with slightly different masses because of those extra neutrons in the nucleus. And yes, carbon-14's decay rate makes it incredibly useful for dating artifacts and fossils.
Wow.
It's like having a tiny atomic clock built into ancient artifacts.
That's amazing. Okay, so we've gone from ancient Greek philosophy to neutrons and isotopes, all in a day's work for the deep dive. But I have a feeling we're not quite done yet, are we? Didn't those excerpts mention something about quantum mechanics?
You're right, we've still got a ways to go. And this is where things get even weirder, even more mind-boggling. Remember those nice, neat electron orbits that Bohr proposed?
I do, yeah.
Well, it turns out that's not quite the whole story.
Oh boy, I knew those neat orbits were too good to be true. Quantum mechanics, that's where things always get a bit fuzzy for me.
Fuzzy is actually a pretty good way to put it. You see, in the quantum world, things aren't so clear-cut. We can't pinpoint the exact location of an electron like we can with a planet orbiting the sun.
Wait, really? So we can't say for certain where an electron is at any given time?
You got it. And that's where Heisenberg's uncertainty principle comes in.
Heisenberg's uncertainty principle. Okay.
It's not just about limitations in our instruments. It's a fundamental limit on what we can know about a particle's position and momentum at the same time.
Okay, my brain's already doing backflips. Momentum, you mean how fast it's going and in what direction, right? So the more we know about where an electron is, the less we know about where it's going.
Exactly. It's a trade-off. It's like trying to take a picture of a hummingbird in flight. The moment you focus on getting it in the frame, its wings are just a blur. The very act of pinning down its location makes its motion uncertain.
So it's not that our instruments aren't good enough, it's just a fundamental fuzziness built into the fabric of reality at that scale.
Precisely. And because of this inherent uncertainty, we have to shift how we think about electrons altogether.
Oh.
Instead of those neat orbits, we now describe electrons using something called waveforms and probability.
Waveforms, probabilities. Okay, now we're really diving into the deep end. What does it even mean for an electron to be a waveform?
It's definitely a mind bender. Think of it this way. Electrons aren't tiny planets whizzing around a sun. They're more like dot clouds of probability smeared around the nucleus.
Probability clouds. That's a pretty awesome visual, I have to admit. But how can a cloud explain all the precise properties we observe in different elements? If electrons are just these fuzzy clouds, how come elements behave in such predictable ways?
That's the beauty of quantum mechanics. Those clouds aren't just random blobs of electronness. They're actually three-dimensional shapes called orbitals, and they're governed by very specific mathematical equations.
Okay.
Think of orbitals like maps of probability showing where an electron is most likely to be found.
Okay, so each orbital is like a probability map for an electron instead of a fixed path. And these shapes, they aren't just like simple circles, right?
You're right. They can get pretty wild. They have lobes, nodes, different shapes and sizes depending on the electron's energy level. And here's the kicker. Only certain orbitals are allowed for each atom. That's what gives each element its own unique set of properties.
So it's like each element has its own electron fingerprint dictated by those specific probability clouds.
Yeah.
That's how we get such a diverse periodic table, right?
Exactly. It's this unique electron configuration that determines how an element interacts with other elements, how it bonds, what color it is, pretty much everything about how it behaves. Now, let's zoom in on the modern atom, shall we?
Absolutely.
Yeah.
We've come this far. Let's see what this tiny universe looks like up close.
All right, imagine this. At the center, we have the nucleus. Incredibly dense, packed with protons and neutrons. We're talking 99.94% of the atom's mass crammed into a space that's unbelievably tiny compared to the whole atom.
Wait, seriously. It's like the classic analogy. If an atom were the size of a football stadium, the nucleus would be like a pea on the field.
Exactly. Most of the atom is actually empty space. But don't let that fool you. There's a lot going on in that emptiness. That's where electron probability clouds come in, buzzing around the nucleus at mind-boggling speeds.
Mind-boggling is right. And it's the electromagnetic force that keeps those negatively charged electrons attracted to the positively charged nucleus, right?
Right.
Kind of like an invisible tether, preventing them from just flying off into the void.
Precisely. But hold on, there's another force at play inside the nucleus itself that's even stronger, holding those protons and neutrons together.
Okay.
Remember, those protons are all positively charged.
Right.
So you'd think they'd repel each other, right?
Yeah, wouldn't the nucleus just fly apart if it's
Right.
all positive charges crammed into that tiny space?
Yeah.
What's keeping it all together?
That's where the strong force comes in, aptly named.
Yeah.
Because it's the strongest force we know of in the universe. It's far stronger than the electromagnetic repulsion between those protons, especially at the tiny distances within the nucleus. It's what binds those protons and neutrons together, keeping the atom from flying apart.
Wow, the strong force. It's a good thing it exists. Yeah. Otherwise, no atoms, no elements, no us. But this balancing act within the atom, it's not always perfect, right? Didn't those excerpts mention something about radioactive decay?
You're right, not all atoms are created equal.
Right.
Some isotopes are unstable, meaning those forces within the atom aren't quite in perfect balance, and that's where things get a little spicy.
Spicy. Tell me more. What happens when those forces are out of whack?
Those unstable isotopes can undergo radioactive decay, where the atom actually transforms into a different element.
Oh.
It's like the atom is rearranging its insides, trying to find a more stable configuration.
So how does an atom just, like, transform into a different element?
Think of it as the atom trying to blow off some steam, releasing energy or particles to reach a more stable state. There are different ways they can decay, like emitting alpha particles. Basically, helium nuclei, two protons and two neutrons bundled together. Or they might undergo beta decay, where a neutron transforms into a proton, or vice versa, spitting out an electron or its antimatter twin, a positron.
Positrons. That sounds like something straight out of Star Trek. It's incredible to think about all these tiny particles and transformations happening all the time, even in seemingly ordinary matter.
It really is, and it gets even more mind-blowing when we zoom out and think about where all these atoms came from in the first place. Remember, we're diving deep into the Wikipedia article on atoms, and it all goes back to the Big Bang.
Okay, back to the Big Bang. So atoms weren't just hanging around, like, right at the beginning, were they?
Not quite. In those first few moments after the Big Bang, the universe was way too hot and dense for atoms to exist. It was more like a chaotic soup of elementary particles, including quarks. Those are the even tinier particles that make up protons and neutrons.
Okay, we're going even smaller than atoms now. So quarks are like the building blocks of the building blocks.
Exactly. It took a few minutes on a cosmic scale, that is for the universe to cool down enough for those quarks to bind together and form protons and neutrons. But even then, electrons were still too energetic to settle down and form atoms.
It's wild to think about those first few moments of the universe, with particles forming and interacting in that extreme environment. So when did the universe finally cool down enough for atoms as we know them to form?
It took about 380,000 years for things to cool down enough for electrons to finally be captured by those atomic nuclei, forming the first atoms.
380,000 years. That still seems pretty fast for the entire universe to cool down enough for atoms to form. And those first atoms, were they the same elements we see all around us today?
Good question. Those early atoms were mostly hydrogen and helium, the lightest elements. To get to the heavier elements like carbon, oxygen, and everything else that makes up our planet and even our bodies, we have to look to the stars.
Of course, the stars. Stars are like giant cosmic furnaces, right? They fuse those lighter elements into heavier ones.
Exactly. It's called stellar nucleosynthesis, and it's how most of the elements on the periodic table were created.
Wow.
Deep inside stars, intense pressure and heat fuse hydrogen into helium, then helium into carbon, and so on, all the way up to iron.
So all those elements listed on the periodic table, they're the result of billions of years of stars fusing lighter elements into heavier ones. That's pretty amazing.
It really is. And for elements heavier than iron, we need even more extreme events, like supernovae, those massive explosions that occur when giant stars die.
Supernovae. Talk about going out with a bang. So these incredibly powerful explosions, they're responsible for creating some of the elements that make up our planet and even our own bodies.
It's true. Those explosions scatter those newly forged elements out into space where they eventually become part of new stars, planets, and yes, even life. It's a beautiful cosmic cycle. The atoms in your body were literally once part of stars that exploded billions of years ago.
That's a pretty mind-blowing thought. But it does make me wonder, if atoms are so incredibly small, how do we actually know all this about them? We've talked about experiments, but how do you even begin to study something you can't even see with the most powerful microscope?
That's the amazing thing about science. We've developed incredibly ingenious ways to see the invisible world of atoms. One way is through spectroscopy.
Spectroscopy. That rings a bell. Remind me what that is again.
It's all about studying how matter interacts with light. You see, when atoms absorb or emit light, they do so at very specific wavelengths, creating a unique pattern. It's like a fingerprint that tells us what elements are present.
So by analyzing the light coming from a star, or even just shining light through a gas here on Earth, we can figure out what it's made of, even if we can't see the individual atoms.
Exactly. It's like having a cosmic decoder ring for the universe. And if we want to see the structure of materials at the atomic level, there are techniques like scanning tunneling microscopy, or STM.
Okay, scanning tunneling microscopy. Now that sounds seriously high-tech. How does that one work?
Imagine an incredibly sharp needle with a tip that's literally just one atom wide, scanning across a surface. It uses a quantum phenomenon called tunneling, where electrons can actually jump across a tiny gap. By measuring this tunneling current as the needle scans the surface, we can map out the position of individual
So
atoms.
we're basically feeling our way across a surface, atom by atom, and creating an image based on that.
Exactly. And it gets even crazier. There are techniques like atomic force microscopy that are so precise, we can actually pick up and move individual atoms around like tiny building blocks.
That's incredible. It's amazing to think how far we've come, from ancient philosophers pondering the nature of matter to literally seeing and manipulating individual atoms.
It's a testament to human curiosity and ingenuity. And the story isn't over yet. There are still so many questions about atoms and the subatomic world. What is dark matter made of? What are the limits of quantum mechanics? Every answer just leads to more fascinating questions.
That's what I love about science. It's a never-ending journey of discovery. So to everyone listening, keep asking questions, keep exploring. You never know what amazing discoveries are waiting to be unearthed.
And remember, as you go about your day, the atoms that make up your body, those tiny ancient particles, were once forged in the heart of stars. We're all connected to the cosmos in a very real and profound way.
That's an incredible thought to end on. Thanks for joining us on this deep dive into the atom. Until next time, keep exploring the universe one atom at a time. All right, so welcome to The Deep Dive. Today we're tackling one of history's biggest mysteries, the Dead Sea Scrolls.
Ooh, exciting.
Right.
Yeah.
So picture this. It's the 1940s. A Bedouin shepherd. He's looking for a lost goat near the Dead Sea.
Oh.
Yeah, it's right. He stumbles upon a cave. And this cave, it's packed with ancient scrolls.
Wow.
This wasn't just any old library, though. No. These texts, some of them, get this, they date back to the 3rd century BCE.
Wow.
And they really shook up how we see biblical history, Jewish beliefs, even the roots of Christianity.
It's pretty amazing.
It is. It really is.
Yeah.
So we're diving into, well, excerpts, actually, from the Dead Sea Scrolls Wikipedia page.
Okay.
So it's kind of trying to piece this whole puzzle together.
It's a big one.
It's a big one. It's hard to overstate, really, just how important this discovery was. I mean, we're talking the oldest surviving copies of biblical books that we have, right?
Right.
We also have texts that never even made it into the Bible.
That's right.
And they give us a glimpse into, well, a really crucial period of Jewish history, I would say. A period that's really essential if you want to understand how both Judaism and Christianity developed.
I think so, yeah.
So let's just get right into it. Like, what are the Dead Sea Scrolls?
Well, we're talking about 900 manuscripts, mostly written in Hebrew.
Okay.
But there's some Aramaic and Greek thrown in there, too.
Oh, interesting.
Yeah. And they were found, tucked away, hidden in 12 caves.
12 caves.
12 caves near this place called Qumran. Have you heard of Qumran?
Come on.
Which is on the West Bank, just north of the Dead Sea.
Right.
And the scrolls cover all sorts of topics, biblical texts. We've got rule books, hymns, even what seem like ancient horoscopes.
Really? Ancient horoscopes, huh?
Oh.
That's pretty cool.
Yeah.
This is incredible to think about the variety of material that's covered in these scrolls, and to think it all started with a shepherd and a lost goat.
A lost goat, I know, right?
So so the shepherd finds the scrolls. What happens after that?
Well, at first, these scrolls didn't get the attention they deserved.
Oh, really?
Yeah, the shepherd, he took some of them to a dealer, but the dealer, he didn't really recognize their value. So it took a while, actually, for the scholars to get involved. And once they did, though, it sparked like this frenzy of exploration.
A frenzy?
Yeah, a frenzy. Bedouins and archaeologists were both racing to find more scrolls.
Wow.
Yeah, it's pretty exciting.
It was a real-life treasure hunt.
Yeah.
With incredibly high stakes, because you could rewrite history with this stuff.
Exactly.
Wow.
And over, the next 10 years or so, they uncovered literally thousands of fragments from those 12 caves.
Thousands.
Wow.
So it's like a giant jigsaw puzzle.
It is, yeah.
And scholars have spent, decades putting them back together. I mean, using all this crazy stuff like infrared photography, even DNA analysis, just to help match these tiny pieces and decipher the text.
Technology has been so important. Yeah.
That brings up a really important point, though.
Yeah.
Who owns these scrolls? I mean, I know there's been controversy over that.
Absolutely.
Right.
Sure.
So where they were found, that's on the West Bank. That puts it right in the middle of the Israeli-Palestinian conflict.
Right.
So while they were initially kept in the Rockefeller Museum in Jerusalem, after the 1967 war, Israel took control.
Yeah.
And this has led to, well, it's led to disputes with Jordan and with the Palestinian Authority, who both say, hey, we own those scrolls.
Right. It's a reminder that even these ancient artifacts can get caught up in modern politics.
So we've got this amazing collection of scrolls. They've been put back together, but who owns them? Still up for debate. So what did they actually find in these scrolls?
Well, think of it as three main categories.
Yeah.
So first, we've got copies of, well, almost every book in the Hebrew Bible.
So what Christians would call the Old Testament.
Exactly.
Okay.
And this was huge because these copies, they're over 1,000 years older than the oldest manuscripts that we knew of before.
1,000 years.
1,000 years older, yeah.
Yeah.
Second, there are these texts that aren't in the Hebrew Bible, but they were around during, the Second Temple period.
Right.
Texts like Enoch, Jubilees, and Tobit.
Okay.
And then third, you've got these sectarian manuscripts.
Sectarian?
Yeah.
What does that even mean?
So it's basically like the rules, the beliefs of one specific Jewish group, possibly the Essenes.
Okay, hold on. Essenes?
Yeah.
Who were they, and why do people think they might have written these scrolls?
So the Essenes, they were a Jewish sect, emerged around the 2nd century BCE,
Okay.
known for being really strict, very into their religious practices, emphasized ritual purity, and they lived communally.
Right.
And they believed in, this big apocalyptic battle, good versus evil. And the Dead Sea Scrolls have this text. It's called the Community Rule, and it outlines all these regulations, strict regulations for members of a community.
Okay.
And it sounds a lot like what we know about the Essenes.
So we've got these rules for communal living. The scrolls were found near Qumran, which might have been an Essene settlement. Seems like a pretty good case.
It does, right. And for a long time, that was the main theory, the Essene theory.
Okay.
But there are other theories out there.
Okay.
And there's some evidence that, maybe it wasn't the Essenes.
Okay.
For example, not all the texts seem to match up perfectly with Essene beliefs.
Yeah, that's true.
And some scholars say Qumran, maybe it wasn't only Essenes living there. Maybe it was more diverse, or maybe it was just a hiding place for texts from Jerusalem.
Okay, so we've got a real mystery on our hands.
We do.
Who wrote these scrolls? Our prime suspect is the Essenes. But it sounds like there's other possibilities, too.
Oh, yeah.
I'm hooked.
And we're just getting started.
Oh, no.
Next time we're diving into those other theories, the Sadducees, maybe Christians, even the possibility it all came from Jerusalem.
Can't wait.
It's going to be a good one.
It's going to be great. All right, listeners, stay tuned because this deep dive is about to get even deeper. All right, so welcome back to the deep dive. We're continuing our investigation into the Dead Sea Scrolls. And last time, if you remember, we left off with that big question, who actually wrote these things?
Right.
The Essenes, they're our top suspect. But there are other possibilities, right?
Yeah, it's like we've got this puzzle, right?
Yeah.
There's a bunch of pieces still missing. We've got clues, but the picture, it's not complete.
Right. So let's look at some of the other suspects, like the Sadducees. They were a completely different Jewish group than the Essenes. Why would they be considered?
Well, the Sadducees, they were kind of the elite, the priestly elite in Jerusalem during the Second Temple period.
Okay.
And they were known for, they had this very literal interpretation of the Torah.
Okay.
They didn't accept the oral law that the Pharisees did.
Okay.
And they were, I guess you could say, skeptical about the afterlife. Yeah, and in the Dead Sea Scrolls, there's this text, 4Q MMT. And it seems like it lines up with Sadducee beliefs and practices, especially their views on ritual purity in the temple.
So based on just one text, some scholars are saying, hey, maybe these scrolls were a Sadducee collection.
Yeah.
Really? Just based on one text.
It does make you wonder if all the scrolls came from one single community's library, or if it was like a mix.
Yeah.
We're dealing with a ton of fragments.
Right.
And it's possible different groups, contributed to the collection over time.
Yeah, that makes sense. Okay, so we've got the Essenes, the Sadducees, and now get ready for this one, because we're going into controversial territory here.
Okay, here we go.
Some scholars, get this, they've proposed a Christian connection to the Dead Sea Scrolls.
Oh, wow.
Yeah.
Yeah, that one sparked a lot of debate.
Yeah, I bet.
Yeah. And it basically comes down to a few fragments, particularly one. It's labeled 7Q5.
Okay.
And some scholars think it could be from the Gospel of Mark.
Really?
Yeah, and and that's a big if it is Mark, well, that would push the date of that gospel way back.
Oh, wow.
And it would have a, huge impact on how we see early Christianity.
That's a big claim.
Yeah.
That's a huge if, though. What do most scholars think about this 7Q5 fragment and this whole Christian origin theory?
Well, I'd say most are skeptical. I mean,
Yeah.
trying to say 7Q5 is Mark, it's based on a tiny number of Greek letters.
Okay, so not a lot to go on.
Not a lot. And a lot of teleographers, those are the experts in ancient handwriting, they say the style just doesn't match early Christian manuscripts.
Oh, okay.
So some scholars, they still think it could be true,
Right.
but it's definitely not the mainstream view.
Okay, it's still fascinating, though, right?
Oh, yeah.
Like, just the idea that maybe, the earliest Christian writings could be tucked away in these scrolls.
Right?
That's amazing.
It is.
All right, so we've got 3 possible authors: the Essenes, Sadducees, and this controversial Christian connection.
Right.
But there's another theory,
All right.
one that completely changes this idea of a single community writing the scrolls. And that's the Jerusalem origin theory.
Oh, right.
Yeah, tell us about that one.
Okay, so this theory says that maybe the scrolls, they didn't come from one community. Maybe they came from different libraries in Jerusalem. Maybe even the temple library itself.
Wow.
And people who believe this, they say the scrolls have so many different kinds of texts and writing styles
Right.
that it seems more like a collection from different places, not just one group.
So instead of like the Essenes carefully writing and copying everything, you're saying it could have been this like big collection from all over Jerusalem, and then they hid it in the caves for safekeeping.
It's a possibility. Yeah. I mean, think about Jerusalem in 70 CE. Chaos. The Romans are attacking. The city's under siege. Maybe people grabbed what they could, their important texts, and hid them in the desert, hoping they could come back for them.
So it's like a time capsule then.
Yeah, like a snapshot of what Jewish people were thinking and believing right before everything changed.
Wow.
And if that's true, if the scrolls really are from all over Jerusalem, well, that means they give us a much broader view of Second Temple Judaism than we thought.
Yeah, that makes sense.
I see.
Okay, so we've got 4 possibilities now.
We do.
The Essenes, the Sadducees, that Christian connection, and now this Jerusalem theory.
It's a lot to think about.
It is. It's like a detective story where the evidence keeps pointing in different directions.
It is.
And that's what makes these Dead Sea Scrolls so intriguing. You really have to think critically.
You do.
You have to weigh the different interpretations. And you have to remember that how we see the past, well, it's always changing as we find new things.
Absolutely.
So we may never know for sure who wrote these scrolls. But the search, just the search itself, I think that tells us a lot.
I think so too. Yeah.
It makes us think about history, about religion, about what it means to be human, what people believed back then.
Absolutely. And even beyond who wrote them, the scrolls, they give us this incredible look into Second Temple Judaism.
Right.
The world where both Rabbinic Judaism and Christianity came from.
Okay, so let's get into that then. What can the Dead Sea Scrolls really tell us about this crucial time in Jewish history? What makes them so important, even beyond just figuring out who wrote them? All right, welcome back to the Deep Dive.
So we've been trying to solve this mystery of the Dead Sea Scrolls, right? Looking at all the different theories about who actually wrote them. But now let's kind of, shift gears a little bit. Talk about what these scrolls tell us.
Yeah, good idea.
They give us this amazing view into Second Temple Judaism, like that time period right before the Second Temple was destroyed in 70 CE.
Yeah, it's important to remember that, right?
Totally.
Like the scrolls aren't just about solving a historical puzzle. It's more than that. They're showing us this world that was about to go through massive changes, where different Jewish groups were, they were wrestling with questions of faith, identity, the future. So paint a picture for us. What were some of those beliefs and practices of Second Temple Judaism? How did the scrolls help us understand them?
Well, one of the most interesting things is it shows just how diverse Jewish thought was back then. We think of ancient Judaism as this one thing, but the scrolls show us, it was much more complicated, like a tapestry of beliefs and practices.
Okay, like that.
Yeah, for example, some scrolls talk about this strong belief in apocalyptic events, like a final battle, good versus evil.
Right, like the end of the world type stuff.
Exactly. A new era was going to start. And this kind of thinking, it was big in some Jewish circles, especially groups like, the Essenes, but not everyone believed it.
So it wasn't just this one belief system.
Right. not at all.
Interesting. So the scrolls kind of change how we view ancient Judaism, show us it was much more complex than we thought.
Yeah, definitely.
Okay, so what else?
Well, they also show us how those Jewish beliefs were evolving.
Okay, in what way?
Well, take the idea of the Messiah.
Right.
Some texts, they describe the Messiah as this priestly leader. But others, they say, no, the Messiah will be a king, like David. And these different ideas about the Messiah, well, they would have huge impacts on both Judaism and Christianity later on.
Yeah, totally. It's like the scrolls captured this moment, like a crossroads where all these different interpretations were competing.
It is. It's fascinating.
It is. And speaking of Christianity, the scrolls, they also help us see the world that Jesus and the early Christians were living in, right?
Absolutely.
Yeah.
While the scrolls themselves, they come before Christianity started, they really shed light on that time period.
In what way?
Well, like the scrolls show how important ritual purity was to some Jewish groups. And you see that in the Gospels, too. And they also show, well, how popular apocalyptic thinking was and that, well, that probably influenced early Christian beliefs about, the end times.
So even though Jesus and early Christians, they're not mentioned in the scrolls still give us this valuable background.
Exactly. It's like getting a behind-the-scenes peek at the world where early Christianity was born.
That's a great way to put it. Okay, we have to talk about the impact these scrolls have had on how we understand the Bible.
Yeah.
I mean, they have some of the oldest copies of biblical books.
They do. They really do.
That's pretty major.
It is. It's revolutionized our understanding of the Hebrew Bible.
Okay.
So what Christians call the Old Testament.
Right.
And by comparing these ancient copies to later ones, scholars have been able to track how these texts, how they changed over time, see the differences, and it gives us insight into how the Bible, how we know it today, how it came to be.
It's like a time machine, huh?
It really is. It lets us look back in the Bible's own history.
That's amazing.
It is.
And I bet it sparked all kinds of debates and new ways of interpreting things.
Oh, absolutely.
Right?
Yeah.
I mean, some of the biblical texts in the scrolls are different from the versions that we're used to.
That's right. Like the Masoretic text. And those differences, they might seem small sometimes, but they have a big impact on how we understand how these texts developed, how they were chosen to be part of the Bible.
It's pretty incredible just to think about the journey of these scrolls. Hidden away in caves for centuries, then someone just stumbles upon them. And now they're giving us all this information, changing how we see history, religion, even the Bible itself.
It's really amazing.
It is. And you know what's really cool?
What's that?
Because of technology, anyone can see these scrolls online now.
I know, right? High-resolution images.
It's amazing.
You can zoom in, see the writing, look at the parchment. You can read the actual words that were written thousands of years ago.
That's so cool. It's like having a museum right there on your computer.
It is, yeah. And anyone with internet, they can become a Dead Sea Scrolls explorer.
Exactly.
And I think that's a good point to finish on, don't you?
Yeah, I think so.
These scrolls, they remind us that the past, it's not stuck in time. It's not just in textbooks. It's alive. It still speaks to us. It challenges us. It makes us think about who we are, where we come from.
That's a great point.
Yeah.
So as we wrap up this deep dive, we really encourage you, keep exploring this. Look at the online resources, read the translations, look into the debates, come to your own conclusions. The Dead Sea Scrolls are just the beginning of a journey of discovery. Thanks for joining us, and we'll see you next time on The Deep Dive.